Okay, welcome back. So my name is Brian Madena, and today we are going to talk about the series of method of evaluating limits, but today we are going to talk about rationalization. From the previous video, we had started, we had introduced this topic of rationalization, whereby we talked about L'Hopital's rule and a little bit of rationalization, where we can use this method, and we did an example there for rationalization. In this video, what I will do is just try to solve the question that I left you with last time, and I'm going to use rationalization. And at the same time, I'm going to use L'Hopital's rule to solve it, so that you can see. And then after that, I think we'll be done for this one, because I'm also going to teach you something a little bit on chain rule. So now in rationalization, what you do, it's just like we did in the previous video. So the question that I left you with in the previous video was, I think it was a limit as t approaches 0. As t approaches 0 of root t plus 3 minus root 3 over t. So the solution, this one based on rationalization, it will be, so on direct substitution, this one gives us 0 over 0. So it's determinant, it's undefined, so we have to employ another technique. So rationalization, what rationalization entails is that we multiply the numerator and the denominator with a complex conjugate, with a conjugate of the side that we want to rationalize. So like in this case, we are supposed to rationalize the numerator, okay, but in some situations you can rationalize, okay, it depends depending, you'll always know how which parts are to be rationalized. So in this case, we have these roots, the roots are in the numerator, so we are going to rationalize the numerator. So we are going to have t plus 3 as the conjugate, plus root 3. Here it will be now root 3. And then the same, okay, so I'll just put brackets like that to avoid confusion. And then we'll also multiply the denominator with t plus 3 plus root 3. Okay, so as said in the previous video, that these ones are usually very important, okay. So if you have a situation whereby you're going to get these shortcuts are usually important. So a plus b, a minus b is a squared, okay, minus b squared. We shall use these shortcuts several times. So a plus b, and then a plus b is equals to a squared plus b squared plus 2ab. Again, this one can be shorthanded because you see these are same, so some people can just write this one a plus b squared, so it's still one and the same thing, so the solution is still the same. So same thing to a minus b, this one yields a squared plus b squared, but in this case now it's minus 2ab. So this one also, since it's same, some people can write it a minus b squared. So these are the shorthands, but usually mostly in rationalization, the one that we use is this one, because what basically it means that this one is a conjugate of this one, isn't it? So like in this case, when you have a plus, so this is our a, this is our b, and this is our a, this is our b, okay. So our a is this is our a, this is our b, root 3. Okay, so the solution now will be a squared. So this one now we can let me just see. So we can write this as I'll just let me just get some time here. So we can write this one as limit as t approaches 0 over a squared. So a squared will be now t plus 3, because the square over square is like that. I mean, square over square root, it cancels. When you square something that has been square rooted, it's cancelled out. So it's in algebra, so I hope you know that. And then root 3 squared is 3, and then the denominator now will be t, root t plus 3 plus root 3. So this one simplifies to t over t into t plus 3 plus root 3. Okay, so plus root 3, and then this t and this t will cancel. So then that means we can write our limit this way. So we can write our limit as t, sorry about that, t approaches 0 over now 1 over root t plus 3 plus root 3. So when you substitute, where there is a t you put 0, you're going to have it's 1 over, the first one will be root 3 plus root 3, isn't it? And this one can be written as 1 over 2 root 3. So this is our solution based on rationalization. So now in the next video, I think in the next video we're going to talk about chain rule, and then you're going to do the same solution. You can just remember this answer here so that we will compare with the next video that we do, and then what that means basically is that we are going to use a chain rule. But you see, like for this one, we cannot use the direct power rule here because of these brackets that are these square root signs that are here. Okay, so that's why we are going to use a technique known as chain rule. So for the next video, I will just introduce chain rule in a few minutes, and then we shall have this video. We shall do this example and see if we are going to get the same answer, which is 1 over root 3 using chain rule, using El Hopital's rule, sorry. Okay, so thank you and have a nice time.